Welcome. In this session, we see how the integration between Process Mining and Business Automation Manager Open Edition automates the enterprise workflows. In modern enterprises, software development lifecycles span multiple specialized systems. However, the transitions between these systems are often unmanaged. IBM Process Mining analyzed this environment using real event data, and prescriptive analysis further identified a positive correlation. As cross-application friction increased, rework increased as well, along with overall process duration and cost. Now, let's see how IBM Process Mining transforms the workflow. It reconstructs the complete end-to-end software development lifecycle, delivering a unified operational view. It analyzes execution at two distinct levels, at the feature level and at the work item level. From this analysis, IBM Process Mining generates a BPMN blueprint directly from real operational data. That blueprint can then be imported into IBM BAMOE, where manual bottlenecks are transformed into AI agent tasks powered by Langflow. Now, let's see how IBM Process Mining transforms operational lifecycle by integrating seamlessly with IBM BAMOE. What we do now is create a new project using our organization mining capability, or multiple process analysis, as we call it. Since we have already connected the features with the work items and imported the object tables, we can select the two projects, connect them together, and let the product automatically do its work. This generates the union between our features, shown in purple, and our work items, shown in orange. What you are seeing now is the full end-to-end software development lifecycle process, including both the higher-level feature view and the lower-level work item view. We can do this because we created an entity relationship diagram. The product understands that these two processes are connected, and it is smart enough to automatically merge them and run the analysis. To complete this demo, we now want to provide the BAMOE developer with a BPMN diagram that can serve as a reference for building the workflow. We could start from this full diagram. However, what I would like to do first is apply some filters to keep only the activities that are part of the path. Let me quickly do that. I am excluding activities such as change request created, build failed, and reopened. In other words, activities that would not normally be part of the standard workflow, so that we can focus initially on the path. You can now see that the model is more straightforward and simplified. Let's look at it from a BPMN perspective. The flow is automatically translated into BPMN. We can see the different applications represented here, so the BAMOE developer knows exactly what needs to be built, in which application, and where interactions between systems occur. Now we simply need to download the BPMN. What I have here is a process that I exported from IBM Process Mining. To import a BPMN file, simply drag and drop it into the BAMOE canvas. Immediately, the BPMN editor appears. We can see different parts of the process and the swim lanes. This is the start of the process, and each box here represents a step. Looking at this workflow, we can already identify opportunities to replace manual steps with automation. One clear example is the security review of pull requests. What I'm going to show now is how to convert a human task, or user task, as we call it in BPMN, into an AI agent task. If you select the user task and change its type to the robot icon, it becomes an AI agent task. You can then connect to external providers, and those agents perform tasks on your behalf. To begin, you can see that no Langflow accounts are currently connected. First, we connect a new account. We select Langflow as the provider, give it a name, paste the API key, which is already in my clipboard, and provide Langflow's URL. This shows the list of available AI agents that can be integrated. Switching back to BAMOE Canvas, we paste the URL and enable the option related to the certificate, since it is invalid for this demo environment. If we return to the AI agent task, we can see that the Langflow instance is available, and the AI agents are listed. For this task, I will select the Security Expert Agent, since this is a security review. For the instructions, I will enter, "Please review this PR," and I will reference a variable that contains the PR link. We have not created that variable yet, so let's do that now. We name it PR link, assign it the string type, and mark it as internal, since we do not want it to be either an input or an output. After creating the variable, we include it in the data mapping for this AI agent task. We now have a field where we can provide test values, allowing us to test the agent together with the defined instructions. To make this more interesting, I will add another AI agent task. This one will be executable as well. We will call it PR review. Unlike the first task, which focuses specifically on security, this one performs a general review. We connect it to the same gateway. The conditions would differ, depending on whether a security-focused review or a general review is required. For this task, we use the same Langflow instance, but select a different AI agent. The instructions remain similar. Please review this PR, again using the PR link variable. We assign the variable type as string and provide a test value. When we test it, we see the generated review comments for the pull request. There it is. The result includes multiple evaluation criteria for reviewing pull requests. This concludes the demo.